So now that you've got an overview of the Executor framework, and we've talked about what thread pools are and the kinds of thread pools that Java supports, let's begin a more detailed exploration of the Java Executor interface and ways in which you can use that. So this is the simplest of the various interfaces that make up the Java Executor framework. And as you'll see, it's really simple. So what you can do is you can essentially submit new tasks for execution via the Executor interface and its one and only method, execute. And of course, because there's only one and only method, Executor is a so-called functional interface that decouples the act of submitting submitting work to the mechanics of how each of the tasks will be run when that worker task is submitted. Each task that you give to the execute method of the Executor interface implements the Runnable interface. And it should come as no surprise, because I think we've talked about this before, Runnable is also a functional interface. And because of that, you can use method references and or Lambda expressions in order to express those computations very concisely if that's what you need for your purpose. So you can basically think about Runnable as being a command to execute. And of course, for those of you who've taken CS 251, you hopefully remember the command pattern, which is a good old gang of four pattern that encapsulates all the information needed to perform an action or trigger an event to run at a later point in time. You can also use the Runnable interface to implement something called the command processor pattern. And the command processor pattern is a so-called POSA 1 pattern. It appears in the Pattern-Oriented Software Architecture Volume 1 book written by my good friends and colleagues at Siemens Research. And what command processor does is it packages a piece of application functionality and basically makes that functionality into an object that can be parameterized, and then allows that particular object to be reused and run in another context. In this particular case, it could run in a pool of threads. So the command processor pattern really deals with concurrent processing, whereas the command pattern really just deals with packaging up some functionality into an object. So command processor is like command on steroids, is the best way to think about it. The way that runnables work, and you can kind of get this from just looking at the interface, is that they define so-called one-way task semantics. And a one-way task does something and returns no results. So remember that. One-way tasks do work, they're given computations to do, but they don't return any results directly. They could do it indirectly by putting something in a queue or writing something to a socket or outputting something to a user interface, et cetera. But they don't themselves return a value. So as a result, anything that you need to do that returns something or has some other behavior besides just doing a computation needs to be performed through so-called side effect. What you typically do with a runnable is you use it to execute in a background thread, maybe the main thread, but often you use it to run something in the background thread. And obviously, in the Executor framework context, this all comes down to how is the Executor interface implemented for any given use case. So is it implemented to use a thread pool? Is it implemented to run on the main thread? Is it implemented to use a single background thread? It really all depends, of course, on how you program it. There's even a single threaded Executor implementation where there is no pool, there's just a single background thread. And that actually turns out to be useful for lots of environments like a smartphone where you don't want long-running computations to take place in the foreground thread or the user interface thread, but you also don't need a pool of threads in order to run things off the user interface thread. So that's the end of the overview of Java Executor. If you're thinking to yourself, gosh, that sure seems simple, you're right. Executor is intentionally very simple. In fact, as we'll see as we go a little further along, it may be a little too simple for its own good. And that's why we have other mechanisms, other interfaces in the Executor framework, like the Executor service or the scheduled Executor service and so on, or the completion service that do more powerful forms of multi-threaded computation.